Today we are going to learn the absolute value linear inequality. As you all know, the absolute value of a number is always equals to a positive number. The absolute value of a number cannot be equal to a negative number. We have done absolute value equation. Now we are going to learn how to solve absolute value inequalities using the standard approach usually taught in an algebra class. That is, learn the rules and apply it correctly. There are four cases involved when solving absolute value inequalities. The four cases to consider when solving absolute value linear inequalities. Now, first case 1. The absolute value of x is less than a, or absolute value of x is less than and equals to a, and the condition is given a belongs to the real number and a is greater than 0. If the if a belong to the real number, or a is the element of the set of real number, and a is greater than 0 means all the numbers are positive. A greater than 0 means the numbers are positive. So if a is a positive number, what will be the possibilities? If absolute value of x is less than a, now if we consider the first case, if absolute value of x is less than a, condition 1, so we can express, or we can write as x is greater than minus a, x is less than positive a. There are two possibilities. As we all know, the rule of inequality, the inequality, the negative sign is involved in the inequality. So the sign of inequality will be changed. So we will change the sign of inequality. If less than sign is given, so it will be greater than, or the greater than sign is given, so it will be changed into less than sign. Now the second condition, if absolute value of x is less than and equals to a. So we can write as x is greater than and equals to minus a, x is less than and equals to plus a. Now case 2, if x, absolute value of x is greater than a, or absolute value of x is greater than and equals to a, where a is the element of set of real number and a is greater than 0, means the a is a positive number. If the absolute value of a number is greater than and equals to a positive number, or if the absolute value of a number is greater than a positive number, what are the possibilities? So we can express as this inequality, the absolute value of x is greater than a, we can write as x is less than minus a. Now the sign of inequality will will be changed. If the greater than sign is involved in the question, so the sign of inequality will be changed into less than sign, or x is greater than positive a. Now if the condition, second condition, if the absolute value of a number, if the absolute value of x is greater than and equals to a, so we can write as x is less than and equals to minus a, or x is greater than and equals to plus a, or positive a. Now let's see case 3. Now case 3 is if the absolute value of x is less than minus a, or the absolute value of x is less than and equals to minus a. Minus a means the a is less than 0 and all the numbers are less than 0. So a is a negative number. If a is a negative number, what are the possibilities and what are the condition or the possibilities? The absolute value of any number is either 0 or positive. Now, as we know, know that the absolute value of any number is either 0 or positive, which can never be less than or equals to a negative number. As you all know, the rule of absolute value sign, the absolute value of a number is always equals to a positive number, or it can be equal to a 0. It can be equal to 0, but the absolute value cannot be equal to a less negative number, or it cannot be less than a negative number. So this is impossible. The absolute value of a number or the absolute value of x is less than minus a or a negative number. So the answer for this case is always no solution. Means there is no value of x which can verify the given inequality. So the absolute value of the number is the so the solution set of the given inequality is a null set. Now consider the case 4. If the absolute value of x is greater than minus a, or the absolute value of x is greater than and equals to minus a, means the absolute value of x is greater than a negative number or greater than and equals to a negative number. What are the possibilities? The absolute value of any number, as we all know, the absolute value of any number is either 0 or positive, as we have learned in above sentence. The absolute value of a number is either 0 or positive. So it makes sense that it must always be greater than any negative number. So as we all know, the absolute value of a number or the absolute value of x is always equals to a positive number, or it can be equal to a 0, but it cannot be less than a 0 number. So all the positive numbers are greater than a negative number. So the absolute value of a number is positive. So all the numbers are greater than minus a. So the answer for this case or to this case is always all real numbers verify the given inequality. Means whatever value we have to put in the inequality, the absolute value of a number is greater than minus a. For example, if we put x is equals to plus 4, the absolute value of plus 4 is greater than minus a. And if we put minus 4, the absolute value of minus 4 is also equals to a positive 4. So the absolute value of minus 4 is equals to plus 4, and the plus 4 is greater than a negative number. So all the real numbers verify this inequality. If the absolute value if the absolute value of x is less than a negative number, so there is no value of x which can verify the given inequality, or the solution set of the given inequality is a null set. Or if the absolute value of x is greater than a negative number, so all the real numbers can verify this condition, and all real numbers verify the condition. So there is no limit, no range. We can use any number replacing x. We can use we can replace x by any number, whatever we have to whatever we want to put instead of x we can put, and the answer will be a positive number, and all the positive numbers greater than negative numbers. So there is no limit, no condition, all real number can verify the condition. Remember and statements remember and statements can be written as a compound sentence. X is greater than minus a, and x is less than and equals to plus 5. So x is greater than minus 1, x is less than and equals to 5. So we can write as in compound form, x is greater than minus 1, x is less than and equals to 5. So the end condition means we can write the inequality in a range form. There is a specified range which is given in the question from the number between -1 and 5. So the range is given in the inequality. Now let's see, we consider the second example. Now how can we solve this problem by step by step? Now example 3. Solve the absolute value linear inequality. The absolute value of x plus 6 is less than 2. How can we solve it? First, we have to write in two inequality form. This is a less than absolute value inequality, which is an example of case 1. First, what type of inequality is given? So this is an example of case 1, where the get rid of the absolute value sign or isolate the absolute value sign by applying the rule. Then solve the linear inequality that arises. So first we have to replace or remove the absolute value sign. So this is not the mean we are when we remove the absolute value sign, so we have to put the plus and minus and no, because we are not very sure about this x plus 6 is a positive number or a negative number. So we just assume for a while, if there is no absolute value sign given in the question, what will be the possibilities? If x plus 6 is a positive number, so how can we express it? Or if x plus 6 is a negative number, how can we express in number form? So there are two possibilities. If the number is positive or if the number is negative, what will be the value of x for these two conditions? So we assume this, the absolute value sign is not there. So for a while we forget there is no absolute value sign. What are the possibilities? If the absolute value of x plus 6, for case 1 is if absolute value of x is less than a, write as my x is greater than minus a, x is less than a. This is a case 1. Now set. The goal is to isolate the variable x in the middle. To do that, we subtract the left, middle and right part of the inequality by 6. So x plus 6 is less than 2. We have these two conditions for case 1. Now if absolute value of x is less than a, so we consider the condition 1 of case 1. The absolute value of x plus 6 is less than 2. So we can express this x plus 6 greater than minus 2. As we all know, the absolute value sign when multiplied by the inequality, if the inequality is given, so the minus, when we multiply by minus sign, so the sign of inequality will be changed. So if x plus 6 less than 2, so in negative form we can express as x plus 6 is greater than minus 2 and x plus 6 is less than 2. So these two possibilities. If the x plus 6 is greater than a negative number, or if x plus 6 is less than a positive number, what will be the value of x for these two conditions? What will be the value of x? So it make a sentence true. Now the second step is we subtract 6 from both the sides. Plus 6 minus 6 at both the sides. Minus 2 minus 6 less than x plus 6 minus 6. Same as in condition 2, x plus 6 minus 6 less than 2 minus 6. Now subtract 6 from both the sides. So we get minus 6 minus 2 minus 8. Minus 8 is less than x. X is less than minus 4. 6 minus 6 plus 2 will be minus 4. So the condition, the range is x is greater than minus 8 or x is less than minus 4. These two possibilities. So the specified range is given. We found the numbers between minus 4 till minus 8. The answer in the form of the inequality symbol states that the solutions are all the values of x between minus 8 and minus 4, but not including -8 and -4. Why? Because a greater than sign is involved, greater than or less than sign is involved. So we cannot include it. We cannot write -8 and -4 in the given solution set in our answer. So the number line, how can we found a number line? As we all know, in x is greater than -8, so x is greater than -8, so the number line moves towards the right, and all the number which are greater than -8 and x is less than -4, so we will move towards the left side. Left side means the number line goes to the left, and where these two lines meet together, we found a specified range, the number from -8 till -4. So finally, we can draw a number line from -8 till -4. And as you have learned in previous classes, the unshaded circle or the empty circle shows -4, -8 are not included in the given solution set. So -4 and -8 are not the element of the given solution set or in our answer. So the number line can be expressed the number between -8 till -4. So this is a graphical solution of the inequality. Now let's graph. Now if the greater than and equals to sign is involved or less than and equals to sign is involved, so we use the shaded circle. As you can watch, x is greater than and equals to -6, so we will move towards the right. Or if x is less than and equals to -2, so we will move to the left side, and we found a straight line and a line segment which has two endpoints. The number from -6 till -2 are involved. This means -6 and -2 are the element of the given solution set, or they are included in the given solution. When graphing compound inequality, the end statement shading stops at the end points. Another way to say it, x is between -6 and -2. So shade between -6 and -2. Now let's move to the second example. Uh, Now consider. Here are the steps to follow when solving absolute value inequality. When we move to the next example, we just revise few steps which will helpful in solving absolute value inequality problems. So, what are the rules? Isolate the absolute value expressions on the left side of the inequality. Means first we try to isolate the absolute value sign by adding, by subtracting, by multiplying or dividing. We can isolate the absolute value expression. Now, if the number on the other side of the inequality sign is negative, your equation either has no solution or all real number as solutions. Means, if you found the absolute value of a number is less than 0, so no value of x satisfies the given inequality, hence the solution set is a null set. Or if the absolute value of inequality is greater than a negative number, so all real number as solution for your inequality. Use the sign of each side of your inequality to decide which of these cases hold. Case 1, case 2, case 3, case 4. Now you can identify by the steps, by the cases, or if you forget the cases, so you have to make a list or you have to make a copy for these cases, so it will help you in solving the problem. If the number on the other side of the inequality sign is positive, proceed to step 3. Now Remove the absolute value bars by setting up a compound inequality. If the number absolute value sign greater than or less than a positive number, so we will move to step 3, means we assume the absolute value sign. If the absolute value sign is not given in the questions, what are the possibilities? So we divide our inequality in two parts. The type of inequality sign in the problem will tell us how to set up the compound inequality. Now step 4. Sorry. If your problem has a greater than sign, your problem now says that an absolute value is greater than a number, then set up an or compound inequality that looks like this. If your problem has a greater than sign, means the absolute value of a number or an expression is greater than a positive number. So the OR condition we will apply in our to our problem. So quantity inside absolute value sign is greater than a negative number on the other side, or quantity inside absolute value number is greater than number on the other side. So the OR condition is given. We will apply the OR condition. The same setup is used for A is greater than and equals to sign. If A is a greater than and equals to sign. Quantity inside absolute value sign is less than a negative number on other side, or quantity inside absolute value sign is greater than number on the other side. The same setup is used if A is less than and equals to negative, if A is less than and equals to a sign number. Now consider the example 1. X plus 4, the absolute value of x plus 4 minus 6 is less than 9. What will we do? First, we add 6 on both these sides, so we can isolate the absolute value sign on one side. Now, the step 1 is example 1, x plus 4 is the absolute value of x plus 4 minus 6 less than 9. So step 1, isolate the absolute value sign. By adding 6 on both the sides, we get the absolute value of x plus 4 less than 15. Is the number on the other side negative? Now you can ask by yourself, the number is negative or positive. So it will help you to move further. No, it is a positive number, 15. We will move on to step because the 15 is plus 15. Absolute value of x plus 4 is less than a positive number. This is a positive number, so we will move on to step 3. Now step 3, set up a compound inequality. Set up a compound inequality means the inequality sign in our problem is a less than sign. So we will set up a 3-part in inequality, means x plus 4 is greater than minus 15 or x plus 4 less than 15. Now we can write this inequality separately. X plus 4 is greater than minus 15, so we'll get x is greater than minus 19. Or if x plus 4 is less than 15, so we get x is less than 11. This is a compound inequality. It means the condition is given x is greater than minus 19, x is less than plus 11. So a specified range we found from the number between 11 plus 11 till minus 19 or minus 19 till 11. The number between minus 19 and 11 and minus 19 and plus 11 are not the element of the given solution set. So let's see the second example. If absolute value of 2x minus 1 minus 7 is greater than and equals to minus 3, the absolute value of a number is greater than and equals to a number. First, isolate the absolute value sign by adding 4. Now it's a positive number 4. We will move on to step 3. Minus 7 will add on both the sides. So plus 7 and minus 7, 3 plus 7 equals to plus 4. So number will be a positive number. The inequality sign in our problem is a greater than or equal to sign. So we will set up a compound inequality with the word or. 2x minus 1 is less than and equals to minus 4, or 2x minus 1 is greater than and equals to 4. We can apply same steps in the first inequality. If the less than sign is given, so we can divide our inequality in two parts. Now, because the plus the absolute value of a number is greater than a positive number, so we will move to the step 3. 2x minus 1 less than and equals to minus 4, or 2x minus 1 greater than and equals to plus 4. Now solve this inequality. 2x minus 1 less than 1 and equals to minus 4. So 2x is less than and equals to minus 3. X is less than and equals to minus 3 upon 2. Now solve the step second inequality. 2x minus 1 greater than and equals to 4. 2x minus 1 greater than and equals to 4. So 2x is greater than and equals to 5, and x is greater than and equals to 5 upon 2. So we found two different conditions. Either the number is less than minus 3 upon 2 means x is lesser than equals to minus 1.5, or x is greater than and equals to 5 upon 2 means 2.5, or x is greater than positive 2.5. We have two different conditions, and this condition is used as or condition, either or. Now let's see the third example. Solve 5x plus 6 plus 4 less than 1. Absolute value of 5x plus 6 plus 4 is less than 1. First, isolate the absolute value sign by subtracting 4 from both these sides. Now, plus 4 will move to the right side. 1 minus 4 will be minus 3. So, isolate the absolute value side. The absolute value of 5x plus 6 is less than a negative number. Now, this means this is the condition of case 3. We will look at the sign of each side of the inequality to determine the solution to the problem. 5x, the absolute value of 5x plus 6 is less than negative number, and positive number is less than negative number. This is, it cannot be possible. So the solution set is a null set, or there is no value of x which satisfy the given inequality. There is no solution to this problem, because whatever value we have to put in this inequality, the answer will be a positive number, because the absolute value of a number is always equal to a positive number. This cannot be equals to a negative number, or cannot be less than a negative number. There is no solution, no value of x which can verify this given inequality. So there is no solution, and the solution set is a null set. Okay, the answer is null set. Now let's move to the fourth example. If absolute value of 3x minus 4 plus 9 is greater than 5, first, isolate the absolute value sign by subtracting 9 from both these sides. We get absolute value of 3x minus 4 is greater than minus 4. Minus 4. Absolute value of 3x minus 4 is greater than minus 4. Is the number on the other side a negative number? Yes, it is a negative number, minus 4. So we will look at the sign of each side of the inequality to determine the solution to the problem. Absolute value of 3x minus 4 is greater than a negative number. As we all know, the absolute value of a number is either 0 or a positive number. It cannot be less than a negative number, and all the positive number greater than a negative number. All positive number greater than a negative number. So the absolute value of any number is equal to a positive number. This rule must be remembered. keep it in your mind, so it will help you in making the decision. This statement is always true, so the solution to the problem is all real numbers verify the given inequality. There is no limit, no value, no range of the x. We can use any number, we can substitute any value of x in this inequality, and all the numbers verify this inequality. So this is the solution. So thank you so much.